Today we're going to be talking about arrays in C#. So an array is just a group of contiguous memory locations that all have the same name and same type. So I'm sure you've used arrays before, but let's just kind of cover them from the beginning. So if we want to create an array, we use whatever identifier we're trying to use for the type. In this case, we're going to create a single dimensional array. Let's call it my array. Now, we can first instantiate this, and you'll notice it even tells me the variable myArray is declared but never used. You'll also notice that arrays are object references, so they're treated as objects. So this is not creating an array. This creates the object reference. Now anything time we deal with objects, we always have to use the new keyword. And when we use the new keyword, you have to say the int, and you also have to say how many elements. So in this particular case, we've declared this object reference called myArray, and we've now initialized it so it has 10 elements that are indexed from 0 to 9. Now we could have put this all on one line also. So a lot of the times you'll see something like this done, where it's the exact same thing, it's just not done on two different lines, but you create an array with 10 different elements and you can index them anywhere from 0 all the way up to 9 in this particular case. And it's extremely common to get an out of bounds exception where if I would put the number 10 here, or 11 or 12, this would crash because it's instantiated an object. It only has 10 elements or 10 integers contained with that array, so you have to make sure it's 0 through 9 because since C# is a zero-based indexed language, like most. So now here, this is an example from the book, figure 8.2, and what it's telling us is that we've got this array that we've created. We're just going to create some stuff on the console, and then we're going to loop through our array for each value. Now, almost always use a for statement when you're looping through an array, or a for each statement, which we'll go over in just a minute. So in this case, we're starting at 0, because again, arrays start at 0, so that's why you're going to have that there. As long as our counter is less than array.length. So this is a new concept here. So what does array.length gives us? Well, it gives us the number of however many elements are in our array. And that's why you see the less than sign, because this is going to return 5 in our particular instance. So we only want to go from 0 and less than 5, which will make this 4 the last time through. And then down here we're just outputting the array. So again, a single dimensional array, and this could be any type. You could have, this could be double, this could be string, this could be anything you want for these particular arrays. So let's go ahead and take a look at the next example now. And in this example, we're going to show you how to pass arrays to other methods. And so in this example, they've created this array called array. That's just a name they called it. And you can see it's an integer array, but on this side, they didn't use the new keyword. All this is it's just a shorthand syntax for .NET and C#, where rather than using the new keyword, it just says, hey, if you already know the values you're going to define this variable from the very beginning, just go ahead and do it, and it'll do the syntax behind the scenes. So this just creates a element or array with 5 elements in it, and they're labeled 1, 2, 3, 4, 5. Now here we have what's called the for each statement. Now this is what I generally use to loop through arrays. The only difference is if I need to know the index as I'm looping through, then I would use just a regular for statement. But the reason a for each statement is nice is that it will guarantee you that you will loop through each array element and only the array elements, because since you're going for each element, you can't go out of bounds. And so I'm going to change this real fast just as we read through it, and I'll change it back in just a second. So what it's saying is, okay, so for each integer in the array, put that value in this variable called value. So each time through, it's sort of like it's saying I equals 0, I equals 1, I equals 2, etc., etc. So the first time through, value is going to hold the value that's in index 0. The next time through, value is going to hold index 1, index 2, index 3, etc., etc. So it's just an easy way to guarantee that you can loop through all of these values. Now the var keyword is a new keyword in C#, and Different people like to use it for different reasons. I personally don't like to use the var keyword if I know the type. So what the var keyword does is it is still what's called strongly typed. It's not a variant type. Like JavaScript has variants, C# does not. So what this var keyword does is it's nothing more than a shortcut so that you don't have to define the word int here. So it's exactly the same as if you actually just put int here. So it figures out basically what you need to loop through. Now this can be nice. We'll learn later in the class as we're looping through objects, especially when we get into generics, and that'll make more sense why the var keyword was created and why it's very useful, especially when we get into what are called link queries. But again, a lot of people use the syntax this way. I prefer to hard code it as like int. That's just the way I like it. I think it's more readable. So then we're going to pass this array to a method. We've got this method called modify array. Now you'll notice that here's my array and I just pass it in with the array name, which is the name of my array here. Now remember, objects are passed by reference by default. So when we come down here, we want to take a look at and notice that here's that signature for how you pass in an array. Now this takes a little bit to get used to, but you'll notice if you just remember that it's exactly the same syntax here when you first define your array. Why is that? Because what we're really doing is passing in an object reference to our actual array since it's an object. And so that's why right here you just pass in the entire object reference to our array, and then this actually passes in, it's now pointing to the exact array. So when you do something like this, it's actually modifying each element within that array because we're actually using the original array. So you need to be careful of that it's not making a copy, it's passing the entire object reference. Then it's going to output the values. Now down here, you can see that we're accessing these individual array elements. So here's a method that's called modify element. And you'll notice here that we're passing in an integer here. So because this is a value type, it's passed by value. So this element, this array sub 3, it's passed in here, it's multiplied by 2, it displays this. However, the original array is not being updated because we're passing in an integer type versus passing in the entire array like we do here. So the next example at figure 819, this is a program for multidimensional arrays. And so here's the syntax for doing that. Now, again, there's always lots of different ways that we can do that. So for instance, we could also do something like this, call it my array. And again, we're going to have our new syntax here. And because it's multidimensional, what we do is we're going to declare how many rows and then how many columns for our array. Another way that you can do it is something like this. So this is going to have 2 rows and 3 columns for our array. So there's always different ways that you can do sort of the same thing. You could also do this on 2 lines exactly like we did with our single dimensional arrays. So here's our multidimensional array, and again, remember, this is the object reference. This is where it actually instantiates the array. You can also do something called jagged arrays. Let me move this over a little bit. Now, jagged arrays, what they mean is that within each row there's actually another array contained within it. And you'll notice that this integer array, so row 0 of this jagged array, has an integer array. It's single dimensional with 2 elements. Same with this, and so each sub-array has a different number of elements within it. I have never in 20 years of my career needed to use a jagged array. It's very confusing, and I would just stay away from it. But again, if it ever comes up, you can use it. There's the syntax. Now we've got this output array, so what we're trying to show here is how you pass an array by reference to a method. And the syntax looks almost identical to over here, how we did it. When we pass this in, you can see that here's our syntax here. The only difference is the comma in between because we're passing in a multidimensional array. Now when you pass in the array, you have to remember that anytime you modify any of the columns or rows, those values in there, you're modifying the actual values in that array. Now for a multidimensional array, you'll have to have 2 for statements, one to loop through the rows and one to loop through the columns in order to completely loop through that. Now a new concept here is this getLength method. So our array up here, we get it for us. We get this getLength method. And what getLength sub 0 on a multidimensional array gives us is the number of elements in this row, in the first, how many rows we got. So you can see loop through the array's rows. So this will tell us how many rows. GetLength sub 1 is getting us the length of the next dimension, which is how many columns. So that's how we get the length of rows and the columns, but do it dynamically, because maybe we don't know how big this array is going to be, how many rows and columns. And so you wouldn't want to hard code this value into your method, because someone else could pass you this array in and you don't know. It could have 5 rows and 6 columns, or it could have 10 rows and 20 columns. You don't know. And that's why you need this. And then pointing out the var keyword again, this could also just be replaced with the int keyword. Now, if I were actually just to say array.length, which is perfectly valid, that actually gives me the complete number of elements. So it's rows time columns, so how many individual elements there are. So just kind of be aware of that. And this also shows you another example of the Foreach statement, but again, you have to have 2 of them in order to have them nested within your array here. Now the next example, this is just one that I've created for us, this chapter 5 and the chapter 8 through 27 arrays. And we're just going to go over the single dimensional, multi-dimensional aspect. Later on we'll be talking about the hash tables and array lists. So what I've done here is I've kind of organized the code a little bit. And so the first thing, we're just going to re-go over how we declare a single dimensional integer array. Here's how we can index and assign values to each element in the array. Here's a simple for loop where you'll notice we've actually hard-coded how many elements we know in our array. And then we're just going to output each element to our little label here and just access each one. Because it was an integer, I had to use the toString method. Down here, rather than hard-coding for, a better way to do that is to use the length property, and that way it can be dynamically passed in. And then here, just same thing, passing or setting the value to your label. Another way we can do it is we can say get lower bound or get upper bound. It's pretty rare that I use those particular keywords. Generally, it's almost always 0, and then the upper bound I can do with the dot length. But I just wanted to show you other ways of being able to do that. Here's a method to pass in our array. So we pass in the entire array as an object reference, and here's the signature that we pass in. And then I'm going to use a for each statement to go through each integer, which I'm going to name it myInt, inside my array that got passed in. For multidimensional arrays, let's open this up. So here I've got an integer multidimensional array. I instantiate the object with 3 rows and 4 columns. Here's how I load all of the values for the first row, the second row, and the third row for each of the columns. Now here I'm showing you that, okay, to do dot length, what is this going to give us? Well, this is going to give us the total number of elements, which in this case is going to be 12. Here's an example of using nested for loops to loop through each of the variables. Now again, you'll notice I'm hard coding it because I knew how large it was, but it's rare that I'll ever hard code these values in here. And here I'm saying I, because that's going to print out each value. I is going to represent the rows, J is going to represent the columns. So here's a better way to do it now, because now I'm using my multidimensional array, but I don't know how many elements in each row and column. So I'm going to do the getLength. So this tells me that this is going to return the value 3. This is going to return the value 4 for the rows and columns respectively. Just another way to do the exact same thing with the get lower bound and upper bound methods. And here's an example of how we pass in our multidimensional array as an object reference. So you can see the only difference is that little comma there, because I'm saying I'm passing in a multidimensional integer array called passed array, and then I'm going to loop through each value and print it out to the label here. So most of this I would assume should be a review for you and just kind of review the basic syntax, because the syntax should be very similar to C++ and Java, if not identical. So with arrays, just kind of jump in, start instantiate them, be very careful of going out of bounds for numbers too high of the indexes, and that's that.